Today in this section I will discuss about the machine learning Coursera machine learning course taught by Andrew Engines of 9 quick solutions. You are in the Smart Polish channels, so I will suggest you it is the last video of machine learning Coursera. So I have very few less number of subscribers. Please to subscribe my channel, like my videos to make me motivated to upload this type of videos. And next time in different language, Python or R, that will be, actually motivate me. So let's get started with that. So before that, I will recommend it you please to go through the video lecture as well as the lecture notes. This is very important for week 9. In these sections, the assignment will be separated in two sections. First one, the anomaly detections, and the second assignment part will be come for the recommended systems. I mean, they're giving the recommended system in the movie ratings. This is broadly discussed in the assignment. Now I'm directly going to the assignment. I already opened this assignment. I'm doing this assignment in MATLAB environments, not in Octave. So my suggestions for the user that already were in the last assignment. So if you feel any problems in the Octave, so we can switch to the MATLAB also. It's very good. Now this is the main program of ex.8. So in the main programs, let's get started. You should have to compute these functions. So we'll go through one by one. So first is the load data examples. This is the visualizations data they're printing. After that we are loading the data here, and we are loading the data of x of for all the rows and first column and all the rows of second column with color of blue and x shift. Okay, and the axis dimension is like that, and x level and y level level data is named as like that. So estimated the data statistics, the second part of the assignment of first exercise.ex.8. So in that case, you should have to visualize the Gaussian fit. After that, they're estimating, I mean, they're calculating the mu and sigma. Mu and sigma is the very essential things that is predicting by using the function to estimate Gaussian. Estimate Gaussian by using this function, they're calculating the mu and sigma. So this function is not completed. You should have to write the code first here for this function. And let me tell one more things. The mu is known as the Gaussian mean, and sigma 2 they are mentioned, and there also it is mentioned as the sigma square. That is the standard deviations. So the formula of the mu is 1 by m summation over I is equal to 1 to m x superscript of I, and the standard deviation sigma, this formula is 1 by m summation over I is equal to 1 to m within bracket x superscript I minus Gaussian mean, I mean mu, bracket closed, to the power of 2. This is the formula. This thing we should have to write in Gaussian, estimate Gaussian functions. So let's go to the estimate Gaussian. This is the estimate Gaussian. These functions, only this much code you should have to write. What about the thing I told? This is the equation for that. Only the two lines you should have to complete that one. That's it. After that I'm cutting this function. No need of this function again. Now come to the main functions, and after that we are calculating the prediction that the point will be in anomaly or not. For that case, we are using the function of multivariance Gaussian. Multivariance Gaussian taking the parameter x, mu and sigma, and it is completed. So this function is already completed. No need to write anything in this function. No need modifications on this thing. So let's go and look at least one time of multivariance Gaussian. Sorry, I think I did mistake something. Yeah, multivariate Gaussian is here. So you can take a look at least one time in the how they are calculating the probability of multivariate Gaussians. This function is already completed. No need to modify, no need to change these functions. Come to the main function again. In the main functions, now we are using the visual fit. Okay, to visualize it. So visualize functions also already completed, no need to change anything. It will automatically visualize your data set, how it is the predictors values and how it's look like with this circle. So let's go to the visual fit and let's take it to, so visual fit is that one. This function is already completed, no need of any modification. Now come to the this, whatever the visual fit image will come, and that image they're giving the name of x level and y level, and the program is fast and you want it, then you can follow the program by using press enter. Now this is the find outliers. So data have the predictions. Now probabilities of the values, this is calculate the probabilities of the values, multi-Gaussian distribution, multi-variant Gaussian by using that. And I already told this function is already completed, so no need to change anything in the functions. So you should have to do one more thing is here, select threshold. Select threshold is a very important thing. You should have to compute this function. Okay, where epsilon will calculate and will calculate the f1. So let's go at there and take a tool of how they're calculating the select threshold. So in the select threshold, this function at here, you should have to write the code to return the epsilon value and f1. And you know f1 is associated with uh, precision and recall. So what is precision and what is recall, you will get the idea, true positive and true negative, how they are distributed in the predictions from there. In a prediction, when the probability of the values is less than of epsilon, then it is come as a false positive. Why it is written as like it is the summations over false when your when your true value, sorry, when your actual values is false, I mean y values is 0, I mean false. Positive means the prediction you are getting as 1. So true positive, false negative and true positive, you will calculate this one. After that you will calculate the precision, and after that you will calculate the recall, and you will calculate the f1 values. Just this much of code you should have to write for that. That's it. Now come to the main program again. So from the main program we are printing the whatever the epsilon value and whatever the f1 values look like. And outliers, it will takes these values only to find the p, which p values is less than of epsilon values. Now we draw a line, draw a red circle around those outliers, because we already draw the picture. Now if we want to hold the picture, and on the picture we want to overwrite, and we are plotting the surrounded line against with the outliers and 1 and outliers 2, and it will take a red color and with shape of 0. Now up to here with the hold off. Now multidimensional outliers, what is the multidimensional outlier? Let's see here. It is the same as we are taking the same data sets, we are calculating mu and sigma values, we are calculating the predictions, we are calculating the p predictions values. Now we are calculating the epsilon and the f1 values also, and from that values we are giving, we are printing the epsilon and f1 value will be like that. After that we are printing whatever the predictions values is less than of epsilon value, those values we are printing here. That's it. So let's run the program, the first program, and x.8. You can run directly by save, after that F5. So data is printing here, x-axis is the latency, y-axis is the throughput. So we'll visualize the fit. After visualization fit, number of epsilon values, we are drawing the circle of blue color. Now we'll detect the anomalies. Where is the anomalies is there? If we found the anomalies, we'll make it into red colors of round shape. See, we found the anomalies of this dataset, which what about the data set is outside of the circles or in the circle ring, we consider that data set as a anomaly data set. Now proceed the program again, and it is checking and it is showing the output that whatever the f1 values and whatever the epsilon values is given here. So here up to here your first assignment is solved. So now go to the second part of this assignment, to the image. In the second part of this image, sorry, in assignment, you will build recommended systems. It is the movie recommended systems or any market price or anything recommended system, but it is a very funny manner, but it is very essential and very important in machine learning to recommend something to movie or recommend something to product to the user. So we will build the model for that. So let's get started with the predictions of movie ratings, how it is doing. So in the movie rating, we're loading the dataset. After that, we're calculating the average movie rating. Suppose each of the movies is 1682 movies is there and 943 user is there, and the movie is rating range from 1 to 5. So I want to print the movie rating to from movie of Y, Toy Story movie name, and we are dividing by 5. I mean the movie rating, whatever the rating is divided by 5, and we want to calculate the mean, so it will print the mean values of the movie just for understanding purpose. Now in grayscale image we are printing the movie rating, so we are giving the movie Y level and X level name here. The main thing is computed from here, that collaborative filtering cost functions. In the collaborative filtering cost functions, for that to proceed that one, we are imported the data first. After that we are taking the number of user 4, number of movies 5. Let me consider create these things very properly. And number of users, or in theoretically they told in subscript I, sorry, subscript U is equal to 4, number of movies in subscript M is equal to 5, number of feature is 3. I mean 3 feature is there, 3 type of movies there, and X values will be considered from X number of movie 1 to movies and 1 to features, and theta is equal to theta number of user to number of features, and Y is the Y number of movies to number of user, and R is equal to R of number of movies to number of users. Evaluation of cost function. How to evaluate the cost functions? So the next thing is a very important thing is here. To evaluate the cost functions, we are evaluating the cost function using the function copy cost functions. Copy cost function takes the responsibility to determine or to evaluate the value of j, where it takes the parameters of those. So let's go to the copy cost function and let's see how it's calculating. So copy cost function is here. So copy cost function collaborative filtering cost functions that will return to you j and gradient, j values and the gradient value, I mean cost values and the gradient values. For that case, we first want to, sorry, this much code is already given. You should have to write something that will return the j and j values, x gradient value and theta gradient value, where j is the cost and j gradient is the gradient of j and x gradient is the gradient of feature. So one more thing I want to mention here, when you will predict very properly the x gradient, then from the x gradient you can predict the theta gradient. If you predict the theta gradient first, then if you then Gauss it and in computation you can calculate the x gradient also. So both are simultaneously dependent to each other. So we are first calculating these things without using regularization. First 3 line here is without using regularizations, and the blue color is here with comment is the value that will, whatever the value it will return to us. And when you will use the regularization term, just you should have to add this term. This is the regularization term, and this term is a regularization term, and this term is the regularization term with the x gradient and theta gradient. And after that we'll get the j and theta values. So sorry, j and gradient value, and the gradient value if you want to print, then the gradient value will give a matrix of 26260 into 1. This matrix it will gives. So let's proceed to the next step. So in that case, when it is completed, we are showing that the j values will be like that. The collaborative filtering gradients that mean, for that case we are checking gradient by running check gradient distance. So what is happening in this function? We are checking the gradient by running this function, check cost function. Check cost function actually it is creating the collaborative filtering problems. So this function is already computed and no need to modify anything in these functions. Therefore, understanding purpose, you can go through it and take a quick tour in this function. Now come to the later, we'll build another things. Collaborative filtering cost regularization will build now. For that case also we'll compute the j values and we'll give the j values here. At this thing, the same thing I already discussed before. Where this you should have to maybe confused about that one. What is that value? It is the regularization term, I mean the lambda value. Now collaborative filtering gradient regularizations will check with the regularizations 1.5 and it will give some values to you. Now in the next part, entering a rating for any user. Suppose you imported some movie and load movie list, and you are giving want to give the movie rating. First, for those many movies, you give all the movies as zero rating only. So you manually rated some of the movies from the data set, like my rating of first movie you give 4, second, third 93 as a 2. Like this way you give this many of rating. After that, what happened? I'm printing this here that the users gives the rating for those movies as a rating of this. I mean my rating of I. This is movies rating for those movies. Now what happened? Learning to movie rating. You gives the movie rating. So what will be the similar movie rating that will refer to you, or it will suggest by the um, by the by the website that if you like love story movie, so love story same movie will be recommended for you. How it is doing in this section. So for that we imported the data. After that we're calculating the y and r. I already discussed this thing. Why while it will check the recommendation r that your rating is very similar or close to the user rating. Suppose whatever the rating is by the systems and your ratings, the differences of this is very close. Actually it is the in theoretical discussions, those of the movie will revert to you or will suggest to you which movie have the differences of your rating and the differences of the system rating is very low. This differences movie will be revert to you and they will suggest to you. Now normalizing the rating here, it is the main important part. In the normalization part I already written this thing something here. This part is already completed. What happened in the normalization part? Subtracting the mu average rating value from all the movie rating. This is very important. Suppose you didn't rate it in other movies, but other rating will be rated by this system. Normalized rating. So go to the normalized rating. In the normalized rating, you should have to find the y mean values, and y mean value will be subtracted from all those movies previously rated. This function is already calculated, no need to modifications, anything is needed in this one. So useful value, number of user sizes, was given. It's not necessary so much. Yeah, initial some optimization set of options will give you the matrix by linear programming calculations with the gradient object on, and after learning of 100 iterations it will revert to you that with the lambda parameter, I mean regularization parameter 10, and theta will be learned from here. F min u n c by using the gradient descent, theta will be theta will be calculated from these functions by using the gradient descent. So when you got the theta value, when you got the lambda values, and you know the learning will be goes to up to 100 iterations. After that, the parameter will learn and they will return to you, and giving the x values, and theta values we want to reshape here. After that, recommended system will learn will completely. Now we are giving the output of that. For you, the recommended system will be like this, where x is your rating into theta is learn parameter from gradient descent, so it is a prediction. So if the predictions, now if this predictions is add with the y mean, I mean the y mean is the mu values. Okay, for each of the movie ratings this thing will be added. Now the movie list will be returned to you. Love movie list, how love movie list is calculated, you can go through it, but this one is already completed, no need of change or modification anything inside the function. So it is here. So from there r and idx sort it in the descent manner. Whatever the movie will be rating for you, this movie will come back to you here, and they're giving this thing with a loop, and you can, it is very easy, you can understand it. So this function will be called computed as main functions. So let's go to the main functions and run it. Sorry, I'm running with the keyboard. So yeah, check it here. Movie rating is giving in the grayscale image, also come in like this many way. So if you calculate the cost function of the parameter, the cost function J values will come to 22.22. Now for different type of movie rating will become as like this, where the first column values and second column values will be look like same. After that, they told that the differences, okay, of the rating movie and analytic gradient and your chooses values will be the differences like this. So if you run this program, so we will calculate for the lambdas values of 1.5, the cost parameter will come at 1.34, and if you calculate the movie as it is further, so it will run the parameters where it will told that the first column and the second column the value will look like same. So from that the differences is now is very less. First differences is very high, so now the differences is decreases. So let's go to the programs. So it is the movie rating by your side. Okay, from your, the predicted movie will come to you after learning the parameters of theta of 100 iteration. It will give some output to you that those many are the recommended movie for you. Yeah, now original rated provided is this thing, and those are the recommended movie for you. On the basis of the below the score, original movie rated by yourself, those are the movie is rated movie for you. You can choose anything from the movie list as your choice. The server will give you to recommended this movie. By the way, after here the thing is complete. Now let me run the programs and cross check it properly submitted or not. So in the meanwhile time, I will request you, please subscribe my channel, like my videos and share my videos. That will make me motivate. So if I get the time, so whole machine learning course of this thing that I will be do in the Python language, because it is a trending language in the market, and every company is doing the machine learning with Python or neither in R. So Python is very essential, so I think I will do it with the Python also. So please subscribe my videos, like my videos. That will make me motivate, and it is the hope for me, that if my channel is going to be monetized, then maybe I will earn from this YouTube something. So it is the kind informations to you. Please do that things for me. So please, I'm running the program. Wait for that, please. Yeah, feedback is all, this thing is all right. So no problems. So in the during the video, if you need this code, please you will go to the GitHub link of like this Pass model 351. In this GitHub link you will get all the code address there. So fine, hope you will and you will do the nice folks. I think you will love this course, so I also do the same. So I like the course too much, and whatever the teaching procedure is very good. So today's up to this much. So have a nice day and goodbye.